All right, so this front page here really just highlights the differences between graphs that you see that are exponentially growing versus exponentially decaying. I'll highlight the differences. You should have had like a preview of the graphs, the way they look from the activity on Friday. So again, this front page, they're not like the questions you're going to deal with, but it just kind of highlights how to set up the tables, how to plot the points, how the graphs look, if it's exponentially growing versus decaying. So they're a little weird. They're different than the graphs you've done previously, especially when you graph logs, but they're a little different, but the setups are the same way. They're still at A, B, H, and K transformation. So to fill out the table, you have to look at the base power of your graphs that you're dealing with. So this number here is what we refer to as the base. It's not your B value, but it's the base power of the exponential. So it has a base of 2. So that's going to kind of give you an idea of how to set up the Y column for these. So to fill out the table, you just take your base and you raise it to each of these numbers. So they're going to give you different outputs. So let's just start with 0 since that's the easiest one. So any number raised to the 0 power is what? 1. All right. I'll show you why here if I have time today. 2 raised to the first is 2. 2 squared is 4. And then you do the negative values. So you do 2 to the negative first, which is the same thing as anytime you have a negative exponent, you put it over 1. So 1 over under 1. I'm sorry, 2 over 2 to the first, which just simplifies to 1 over 2. So this is 1/2, which is just the reciprocal of this. And 2 to the negative 2 would be 1 over 2 squared, which is 1/4. Just the reciprocal of that. Okay, so all of these 6 graphs here don't have any transformations. So your starting point is at the center. Okay, so we call this the ghost point. Wherever your starting point is at, we call that a ghost point because it allows us to see where the asymptote is located for these graphs. So we plot the points from the center. So like you traditionally do, because these don't have a transformation occurring. So you have 0, 1, it's 1 point, and then you go right 1, up 2, right 2, up 4, and then you graph the left side of the starting point, which would be kind of difficult because you have 2 fractions, but left 1, up 1/2. So it's going to look something like this. Okay. So hence why there's an asymptote, because the further left you go, your Y value is going to become smaller and smaller. So it's going to infinitely approach, like it's going to infinitely get closer to the asymptote, but it'll actually never equal or cross over that line, the imaginary line. So this is how your graph turns out to look like. So that's why when I tell you, when this number is bigger than 1, your graph is exponentially growing. So it should be going up like this. So it kind of replicates like the idea if you're like investing money that has an interest rate that's applied to that amount, that initial amount, where your money's going to grow over time. So it should resemble a chart or a graph that looks like this. Okay, so the opposite is when you have a base power that's between 0 and 1. So basically a fraction. So you'll see the difference of the graphs here in a minute. So to set up the table, it's done the same way, except you have a different base power. It's 1/2 instead of a 2. So same thing. Any number raised to 0 is 1. Okay, 1/2 raised to the first is 1/2. 1/2 squared is 1/4. And then you just do the reciprocals of these two. So this would be 2, and this would be 4. And then again, this doesn't have a H or a K yet, so that means you're going to start at the center. So wherever your starting point is at, draw like an open circle, or just like a ghost point is what we call it, because you're not going to use it, but you're going to use it to graph the other points. And then draw your horizontal asymptote through there. it sets like a boundary, so to speak. An asymptote, like this. So it's an imaginary line that your graph infinitely approaches, but never touches or crosses over. Asymptote. So 0, 1, left 1 up 2, left 2 up 4, and then right 1 up 1/2. So you should see the graph is decreasing in this direction now. Alright, so this could replicate, any example or situation that's losing like value or decreasing in size exponentially, okay? So that's why the graph's decreasing. But these are just like rough graph sketches that don't have any transformations applying. So we'll get to those on the next page. I could do these other 4, but they're all pretty much done the same way. Do you want to see those done? It's up to you. Just know the only thing that's going to change are the tables. It's like this is going to be 3, 9, 1/3, 1/9. Okay, on this side it's going to be 1/3, 1/9, 3, 9. The ghost point's still at the center. It's just going to be different points you plot, but they're going to look like the first two. Okay, so let's go to the back, because these are more of the type of questions that you're going to be doing with on the assignment. All right, so I'm going to skip 1 really quick and go on to 2, because example 2 has all 4 transformations. Okay, so that way you can see where A, B, H, and K are located for these style of graphs. So this is A, this is B, this is H, this is K. Okay, so this example has all 4 transformations occurring. And then remember, this is your base power. It's not your B, it's your base. There's a difference of those two. So if there's an A, it's in front of your base number. If there's a B, it's outside the parentheses. H is inside. K is at the very end. But the way you apply the transformations to the table, in the graph, it's all done the same. Okay, we're almost at the end of the school year, so they're done the same way. So for this one, your ghost point is going to be where H and K is located. So -3, -4. So there. So this is where your horizontal asymptote is going to be for when you make the sketch of this graph. So it's shifted to the left 3, down 4. All right. So from here, you fill out the tables. So you should notice that the tables are shortened from the front, because really you only need 3 points. So we cut out -2 and we cut out +2, because most of the times those are pretty difficult to plot on the graph, because it's like a really small fraction or a really large number. So we just narrow it down to 3 rows. All right. So our base is a 1/3. That's going to tell us how to set up the Y column. So let's do the easy one. What goes for 0? What number goes for 0? Okay. All right. And then 1/3 raised to the first power. It's itself. So that makes -1 what? 3. So these are the original sets of numbers. So then you have to go back and apply the transformations like you have been for every graph, every new function that we study, for every graphing of the functions that you do by hand. It's the same way. So you're going to multiply, since B is a 1/3, you're going to multiply the x's by 3, because you reciprocate it. Since A is 2, you're going to multiply the y's by 2. So you get -3, 0, 3, and then you get 6, 2, 2/3. So these would be the new numbers that you plot on the sketch. So, and it's from this ghost point now that you plotted. Okay, so you're going to go from here, you're going to go left 3, up 6. So that's your first point. 4, 5, 6, yeah. And then from the ghost point, you're just going to go straight up 2. and then you're gonna, from the ghost point, you're gonna go right 3 up 2/3. So it's like not even up 1, it's barely up some, like almost at 1, but not really. So just by looking at the base, it's a third. You should know that your graph is going to be exponentially. It's really called decaying, because for exponential functions, your graph either grows, so it represents growth, or it represents decay, like something that's decreasing. So it'll look like this, and then we just fill out the domain, range, and the equation of the asymptote. So domain. Basically stating what's the furthest left to the furthest right, these graphs. Yes. All real numbers. And then the range. So for the range, yeah. Lowest to highest. All right. So -4 is what we use as the lower bound, or the upper bound, depending on how the graph looks. In this case, it's the lower bound. So that's where your asymptote is located. So we can't include it, okay, because it's imaginary, and the graph, no point actually ever touches it, so we use parentheses around it, and of course for infinity we do too. So both of those numbers should have parentheses around. And the equation, yeah, y equals -4. So hopefully after this, you know the difference between like a y equals and x equals line. All right, so we'll do another one. We'll do example 1. So notice this example doesn't have an A, because this is your base power. Okay, base power is a 2. It doesn't have a B. All it has is an H and a K. So the only transformation that's going to happen is your starting point, your ghost point for this graph. So you're going to go right 3, up 4. So that's where the horizontal asymptote is going to be. So that means whenever you construct the table, you're going to leave those values alone, because there's no A or B value. So this would be -1, 0, 1. And then again, to get your y values, you have to pay attention to your base power. It's a 2. So 2 raised to the 0 power is 1. 2 raised to the first is 2. And then if you don't want to think about it, what 2 to the -1st is, just reciprocate this number. So 1/2. And then those would be the points you plot. So from here you go left 1, up 1/2. From your ghost point, you go up 1, and then you go right 1, up 2. So the graph is growing. Okay, looks like that. So from here, just fill out the same information. So all real numbers, or interval notation, -infinity to infinity, or inequality notation, -infinity, less than x, less than infinity. Set notation we don't use, so, or I would say it. So the range, lowest to highest, should be +4 to infinity, parentheses around both. And then the equation of the asymptote is y equals to 4. At least I'm not writing and erasing with my other hand as I write, like this. Yeah, you'll experience that soon. Many teachers.